Okay, guys, we got quite a bit to cover today. So last time we talked about utility classes. Guys, please, one person talking at a time in the classroom. Otherwise, it will decrease your learning quality. Okay, it's really for you. Okay, so all you need to know about utility classes is you have a class, and everything is going to be static. I'm going to talk about static again in just a moment. What I would like to begin with is I would like to talk about the distinction between public and private. Okay, it's called visibility modifier. I'm going to go over some slides first, and then I will show you illustration on the Eclipse. Okay, one thing to tell you. So if you go to the course website, I uploaded the source code for today. So let me just tell you where to get it. So remember, we actually got the course website for the section over here, right? So if you go there, you will see there's a link to the lectures. If you go there, you will see today we're going to use two code examples. One is called visibility, which we'll use first. And then we're going to have circle utilities. We'll use that second. And I'm going to show you how you can import the zip file into Eclipse in just a moment. I'm going to do that from scratch with you. But I'm going to go over some slides, and let's see how well we can do. Okay? Conceptually, the distinction between public and private is actually quite easy. It's really about to what extent you can access your classes. That's really the issue there. And I'm going to explain to you. Okay, so let's review very quickly. Remember last time, the very first example we did, we got three packages. We got furniture, we got shape, and we have also animal, right? So we're going to continue with this example over here. Let me tell you something about, so that's kind of the structure you should really have in your mind. So at the top level, we got projects. Within the project, you can have as many packages as you like. In this case, we got three packages. We got animal, furniture, and shape. Within each package, you can have as many classes as you like. You got project, package, and class. Okay. So these are the simple contexts we are going to study: private, public, and there's some implicit modifier which you may not know about, which is for the package level access. Let's just go. I'm going to talk about visibility for two categories of things. The visibility of classes, which is slightly easier to understand. And then we'll go to the visibility for attributes and methods. So, but they're kind of similar. Okay. First of all, let's talk about visibility of classes. So there's only one modifier for your class. You can either say class cat, or you can say public class cat. You cannot say private class cat. It's simply not allowed in Java. There's only one modifier for class. That's something to note. So it's either public or not public. Okay, private is not allowed. So what do we really mean by visibility of a class? It's really about to what extent you can use your class. Remember, let's say, I'm sure you have used import statement in Eclipse, right? Or in Java. Import simply means I'm trying to make use of some other classes out of my current projects or out of my current packages. That's why I use import. So the visibility of classes is going to affect the way you do the import. Okay? I'm going to show you an example in just a moment. Let's talk about concept. First of all, the first possibility is, let's say if I declare a class with no modifier. For example, if I simply say I declare a class chair, this means I can only access chair if I'm in the same package as the chair, which is furniture. Okay, and I'll show you a diagram in just a moment. The second possibility is you can let's say if you declare some class as public, you can see now I am adding one additional keyword, public. I say public class chair. In this case, so that simply means any classes in any packages, as long as they're in the same projects, they can access the chair. Okay, let me show you some diagram, then you'll be very clear, and then we'll see examples. So now we're going to consider the chair class. Let's say that's the first possibility. You can see here, I am declaring the chair class as just class. There's no public. So that means the scope of accessing this particular class can be any other classes within the same furniture package. Anything that's outside, that's not within the scope. If you try to access the chair, it's going to tell you it's not visible. I'm going to show you in the Eclipse. Now, the second possibility is if you say public class chair, in that case, everything in your project can get access to it. Is it clear so far? Let's illustrate that very quickly. So once you understand the two differences, either public or not public, when we talk about visibility of attributes and methods, we're just going to add one more possibility. Okay, let's talk about classes first. So if you go to the course website there, under lecture recordings, you have the Java zip file. I'll show you how to do it. By the way, in case you don't know how to import the archive file, like a zip file, into your Eclipse, you can go to, first of all, my homepage over here, and it's simply eecs.yorku.ca, tilde, Jackie. Go to tutorials, and under there, I'm going to add more videos as we go on throughout the semester. So what you want to really watch is this importing a project from an archive file. I'm going to do that in the class with you together. Okay. Now my assumption is we already downloaded the visibility.zip. So that's the first example we're going to see together. So now let's go to your Eclipse, and now I'm going to have a workspace simply just on the desktop. Doesn't matter where it is. Okay. I'm going to say OK. And once I launch, I'm going to import a project so you don't have to type. So please make sure you know how to do this. I'm going to distribute the source code, hopefully before class, to save your typing. So close that. So now I'm going to say, so now there's no project there. I'm going to import that. You will say File, and then Import. And you're going to type EX, standing for existing. What you're going to say is existing project into workspace. And then you will say Next. And now select the radio button for select archive file. Okay, archive file means the zip file. And then you go for Browse. Because I saved it on my desktop, go to Desktop, and then select visibility.zip. Okay? If you say Open, it's going to show you that we got this many projects within that particular zip file. I got about 5 or 6 projects for you to try. Okay? And then you say Finish. And then everything's there, magically. So you don't have to type anything from scratch. So now you can see this visibility example, 1, 2, 3, 4, 5. I'm going with this order. Let's go for number 1. For number 1 and number 2, we're going to illustrate the difference between package level class visibility and project level class visibility. First of all, let's see the package level. So now you can see that the structure here, we are familiar with that, animal, furniture, and shape. Under the shape package, we have a class. Oh, sorry. Let's go to furniture first. If you go to the furniture package there, you see the chair. Okay. Now, by the way, if you want to adjust the font for your Eclipse, what you can do is Eclipse and go to Preferences. Let's do that now. And then you can simply type fonts under General Appearance, Color, and Fonts. What you got to go is go under Java, and then under Java Editor. Double click on that. Let's say I want 18. Okay? And say OK. Okay, that's much bigger. It's much better. So the code there, you got lots of comments there. I'm not going to read it line by line. So let's say over here, we have a class called chair. And you can see it's not public. According to what we just learned, if this class is declared as non-public, only classes within the same package can get access to it. For example, let's go back over here. If you go to the desk class, which is within the same package, if you go there, you can see I can now try to import that particular class. Oh, not the, yes. So I can say import. That's something I should add in the code. I'll fix that after class. But you can simply type import furniture dot chair. You can type that. However, the reason that I didn't put it there is optional. Do you think this is necessary? No, actually, because by default in Java, everything that's within the same package can be accessed right away. Okay? Because that's at the package level, so we don't have to say import anymore. If that's in another package, you have to say import. Okay, so I can safely delete this line over here. So over here, inside this desk, I can just use the package, the chair class in whatever way I like. On the other hand, let me go to another package here called square. Now in the square, it's called the square. Yeah, in the square class, you can see I'm trying to use the chair class. However, you can see there's some red underline. There's an error. If you move your mouse over there, it tells you the class is not visible. Now you should know why. It's exactly the same situation over here. You can see we declare the chair class over here without public. And we are trying to get access to it from the square class over here, which is outside its scope. Okay, is it clear? Okay, so that's not allowed. That's why there's an error. How can we fix this? If you really want other packages to access this particular class, you better declare that as public. That's your only choice. So that's why if you go to the second example over here, it's called visibility to project level class. If you go there, the only change I made was if you go under furniture and go to chair, you can see now I do have public over here. If I now declare public, not only within the same package, but across the packages within the same projects, I can access this particular class. Okay? So now if you go back and then go to shape and then go to square again, in this case, we can access to it without any problem. Okay? So that's about visibility for classes. Any questions? Questions? Yes. Oh, just by default. So basically, you can think about package is like a folder, like a directory on your file system. It's basically saying, if we are within the same folder of the file, you don't have to bother to say import that particular folder, since they share the same folder. Well, how that works, of course, it's a computer does some magic job under the hood. You don't have to worry about how that works. I'm just trying to tell you how it is going to behave in Eclipse. Yes? I would say usually if you know that you're going to make your class available for other people to use, you better make it public, yes. But sometimes, well, again, having public or non-public, you cannot say one is wrong, the other one is right. It really depends on what you need, right? For example, it's like, am I going to measure my driving speed in miles or kilometers? Well, it depends, right? If I'm in Canada, I better do it in kilometers, not miles. If I'm in the States, it should be the other way around. It's something like that. Okay, now that's about the visibility of classes. Let's talk about the visibility of attributes and methods, which is basically the same idea. But now there's one more complication, just one more. We used to say either public or add a package. But now for attributes and methods, we add one more. It can be public, it can be package, or it can be private. So there are 3 levels of visibility here. Okay, but it's not too bad. I'm going to show you the diagram again, and I'm going to show you in the code how they're going to work. Okay, so now let's go to, so now for attribute and methods, so they are going to be applied the same rule. Okay, so first of all, so there are two, well, we used to get only one modifier for the class, which is public. Is public or not public? But now, for attributes and methods, we got 2 possible modifiers. It can be public or it can be private, 2. Okay, it can be either public, and the visibility, there are 3 possibilities, either public, private, or no modifier. Okay, I'm going to show you how that works. So now, for example, the most restrictive attributes or method you may have is to say private. Okay, for example, you might say private static int I. That's a private attributes. Or you might say private void m. So that's a private method. Okay, so these 2 attributes or methods, they can only be accessed within a single class. Anything that's outside this class, even if they are in the same package, they cannot access to it. So that's a new bit. Okay. Now, second one, you can access a particular class within the same package. So that's kind of the default, no modifier. If I say static int I, no public, no private, that's kind of the middle level. Or I can say static void and m, that's also middle level. I'm going to show you to you. Also see the diagram. The least restrictive or the most free visibility you might have is public. In this case, anything in your projects, across packages, across classes, you can access to it. You can either say public static int I, you can say public static void n, right? Okay, any questions until now? Let's see the diagram. It will be quite obvious to you. First, the most restrictive. If I declare attribute I as private, or if I declare method m as private, only those methods within the same class, which is chair, can get access to them. If you try to access these two things, either outside, either in a different class, but within the same package, no, you cannot do it. Or you try to access it within a different class in a different package, of course you cannot do it. Okay? The only thing you can access to it is within this particular class. Second case, if you don't have any modifier, you only say integer I or void m. In this case, any class that's within the same package, which is furniture, can get access to it. Any classes that's outside this particular package, you cannot do it. Okay, that's quite obvious, right, from the boxes I drew over there. Finally, if you simply make I and n public, that means any classes, any methods from your projects across packages, across classes can get access to these two things. Any questions about this? Okay, let's do Eclipse. Okay, so I'm going to show you three cases. I'm going to show you all the three possibilities. Let's go to Eclipse again. So now if you go to the Package Explorer, in case you don't see it, you can go to Window and Show View. And you will see the typical ones you need in Eclipse will be console, which you can see your output. Or you can go to the outline. Outline, you can see the attributes and method within the same class. Or you can go to the Package Explorer, where you can see all the packages and also all the classes. Okay, we have seen number one, number two already. Let's see number three. For number three over here, we're going to demonstrate if we declare the attributes and method as private, what's going to happen? Okay. First of all, if you expand it, go to furniture, and let's go to chair, first of all. Don't worry about the class anymore. Okay, we already talked about the class already. Okay. You can see private static int I, private void n. So both of them are private. You can see it is okay to access these two things within the same method, within the same class. This is just another method within the same class. It's absolutely fine. Just one subtlety to this. When you are trying to get access to the static attributes or methods, if you are in the same class, you can simply just refer to the name of the attributes or method. Okay? However, if you're outside that particular class, you have to qualify that. You have to say chair.i or chair.m if you're outside, just to give some namespace. But here I'm just showing you both possibilities. Okay? Okay, that's about within the same class. What about outside this class but within the same package? No, you cannot do it because they're private. If you go to desk, let's say we have a desk method over here. So they're in the same package. You can see that we have a method called desk method, and we are trying to say chair.i and also chair.m. If you move your mouse over there, it's going to tell you chair.i is not visible because it's private for this, and the similar reason for chair.m. Clear? Okay. So now, let's go a little bit further. Within the same package, we can get access to it if it's a different class. What about in a different package? Well, it should be quite obvious. Should not be either, right? So let's go outside that package there. Shape is a different package, and let's go to square, for example. Now, in the square class, we are trying to use chair.i and chair.m. Of course, we cannot because they are private. Okay? Now, let's go to the next possibility. What about they are declared as neither public nor private, which means they are accessible within a package. So if you go to number 4, and let's go to chair, the furniture, the chair over here. You can see now we remove the public, we remove the private as well. So it's only static int, static void, right? So now within the same class, of course, you can get access to it, okay, as before. Now what about within the same package but a different class? Yes, you can, because you didn't say they are private, so you can do that. So now if you go to that same package there, go to desk, and now you're able to say chair the I, chair the N. But in the previous case, you could not because they were private. Now, what about we go to another package? No, right? Because it's only to the extent of the current package. Very good. Okay. So now let's go there. Shape is a different package, so we go to square over here, and then over here, you can see, no, you cannot do that. If you move your mouse over, it's going to tell you it's not visible. Okay? Now, final case, which is very, very free. Okay? So now, basically, you can see that if we go to the animal, sorry, not animal, furniture. If you go to furniture packaged over there, you got chair, and chair there, you can see public static int, public static void. So they're public, which means anywhere within the projects. Across the packages, across the classes, you can get access to it. That's why if you go to, again, you go to desk, you can get access to them. There's no problem with that. Even if you go outside that package, if you go to a square in a different package, and now you can see that you can also do it, right? So you can see the principle is not that difficult, but somehow just the information that's available usually online, they don't really try to give you some visualization, which I try to do that here. So hopefully that's kind of clear to you. Yes?
How about visibility like between projects? Is there a way to...
Between projects. You know what, I don't want to tell you, I do have a good guess, but I'll tell you maybe next time. Okay, yeah, it's a good question. So the question was, how can you say, I want to access any class outside my projects, maybe somewhere in my computer or over the network? I'll look into that and tell you. Good question. But as far as the course contents are concerned, if you understand these three possibilities of feasibility, you're okay. Questions before I move on? No? Okay. The next topic, I would like to go back to our visibility class. So now we're done with visibility. So now I would like to talk about utility classes again. So now, from now on, our discussion, we don't have to worry about public, non-public, private, non-private anymore because we handled that issues already. So this particular category of modifiers is only about visibility. Okay? So let me just put a note for you. So let me just write something here. So we talk about basically modifiers. You can see that, right? Sorry. So we talk about modifiers. So there are three categories. So the first category we just talked about is called visibility. And for visibility here, it's either at the project level, or it can be at the package level, or it can be at the class level. In the case of the class level, you would say private. In the case of project visibility, you would say public. Okay, so here just none, not there, by default. So that's the first category. And the second category I want to mention very quickly, I think you learned about it already back in your first year. It's called final, to make something that's constant. I'll show you something very quickly on the paper, on the iPad. So it's really about whether it's a constant or non-constant, constant or variable. Okay? So for example, if I say, let's not worry about public, okay? If I say final double pi is assigned to, with some initial value, 3.14. If I say over here, you can see that the thing to notice over here is final. Right? We got final here. What does it really mean when you declare some attribute as final? That means you cannot reassign to it. For example, if I try something like this, if I try, after this, I say pi is reassigned to 6.28. If you try that, it's going to be an error because it's constant. Okay. On the other hand, if you try something like this, if I say double my pi is assigned to 3.14. And notice the difference. I kind of called it in a similar name for purpose. So now you can also see the convention here. Over here, you can see that it's lowercase, uppercase. That's more like a naming convention for variables, right? Only it's like a compound word, but only the first word are all lower cases. And this one is all capitals. That's a naming convention for constants. Okay, so now what about for this one here? If I declare this particular thing over here without the final, that simply means my pi is a variable. And variable literally simply means you can reassign its value for as many times as you like. Okay? For example, I might say over here, I can say after this, I can say my pi is assigned to 6.28. And this is absolutely okay. Okay? Questions? Final is very easy. Oh, let me just say one more thing. So here we talk about very simple assignments for primitive values. When I say primitive, I mean double, Boolean, integer, or character. However, when we talk about reassigning the values for primitive values, later on we're going to talk about classes and objects. Reassignments in that kind of context has a slightly more tricky meaning. I just want to give you a preview, but I'll talk about it when we get there later. Yes, questions? Okay, very good question. So the question was, if I have something like this, I'll put it aside. For example, you might have final static int, I'll just say foo. For example, okay? There's a case study here. What does this mean? First of all, let's see what we have learned. We have learned about what integer really means, right? It can be 2, can be 3, can be 4, anything. And over here, when we say final, that means you cannot do things like this. You cannot simply do, if I say foo is assigned to be, huh? Oh, guys, tell me, okay, good. Oh, that's something I gotta remember. I gotta turn off my screensaver next time, yes. Funny enough, it's because 3311 yesterday, I didn't do too much iPad, that's why it didn't come up. Okay, that's good. I'll try to remember. Very good. Okay, now in this case, if I try to do foo is assigned to be 4, I would trigger an error because that's a final. Okay? Now, what about static? I know static is very tricky. I would say as far as now is concerned, whenever you have either an attribute or a method that is called static, that means if you want to use it, let's talk about how you can use it. Okay? And I'll talk a little bit more later today about what it really means. Okay? So when you say static over here, that means you must access this using its class name. Okay, what do I mean? Let's say, let me just make it a little bit cleaner. Let me add a new page. Make it absolutely clear for you. Let's say over here, if I have just a class over here, let's say my math. Over there, I have, let's say, public static integer and foo. Initially, it's 3. So this is one particular class. Oh, that's not good. Anyway, it's kind of short. Let me try again. Never mind. Sorry. I'm just having fun. Okay, that's reasonable. Okay, I just want to draw a box. I'll practice. Okay, let's say that's a single class we have defined. Now, how can we use it? Let's say we talk about another class over here. I'll put it here. This is another class. Let's call this class here, let's say class my math user or application, doesn't matter. And usually, if you want to have some application, you better have a main method. As I said last time, main method simply means it's the entry point of execution. Okay, so you're gonna have public, static, void, whatever, and then you have main. Okay, that's not important for this discussion here. So now, how do we use it? Okay, now let's say the way to use it is you're gonna say my math dot foo is assigned to 4. That's how you use it. You can see that over here, the reason that we are using my math over here, you can see, right? We are using a class name over here. But later on, we're going to talk about object orientation more, in which case you're not going to use a class name before the dot. You're going to use an object name before the dot. Okay? But for now, let's not complicate the matters. As far as the utility classes are concerned, because everything is static, having a static attribute or method means if you want to get access to them, you have to use a class name to access to them. Okay? Okay, let me just put some notes for you. We can only use the class name to access these attributes because it is static. So whenever you see something that's declared static, that means there's only a single copy at the runtime, only a single copy. And because there's only a single copy, so you just have to use a class name to get access to it. When we later on talk about non-static attributes, in which case you can have as many copies as you can at a runtime, in which case you are going to actually use the object name. Yes?
Like generally without static, won't you have to declare the class if it's in another Java class?
Sorry, say it again. I don't quite get your question. Yeah, say it again.
So the class myMath and myMath user are two different classes.
There are two different classes. That's correct.
So you said since it's
Yep, go ahead. Yep.
you said since it's static, you have to declare the class, right?
Mm-hmm.
So assuming it wasn't static, you could just write foo.
Yeah. You know what, guys? How about we really spend time to really make you understand? Let me compare and contrast. Okay, remember this particular note. I'm going to go back here. I'm going to give you another one. Let's make, the only thing I'm going to change is I'm going to take out the static, and then I'll let you know what's going to change. Okay, let's do a little bit preview. I think that's worth it. So let me just add another page over here. Okay, so now let's do it again. Okay, again, I'm going to have one class over here. Let's call that class myMath2. Okay, and I'm going to have the same similar attributes. Let me just remind myself. It's I'm going to say public int foo. I'm just no static. Public int foo. Okay, just that. Don't worry about the initial value. Let's say it's just 0, default values. Okay, you can see, first of all, we have to notice that this is so-called a non-static attributes. And what difference does it make? So here comes the very important distinction between static and non-static. When you say everything is static, that means that you have only a single copy in your runtime, only a single copy. When you have non-static, you can have as many copies as you like. Let me illustrate it to you, how it's going to work. And I'll visualize that as well. First of all, let's now do a very easy class over here. Again, some application over here. I'm going to say class my math 2 app, for example. And then I'm going to say the main method here. Okay, so now that's non-static. So that means we can create instances for that particular attributes. Okay, let me write the code and I'll visualize that for you. I can say my math 2. You kind of learn about the concept about constructor back in the first year, right? Let me just use constructor for now. I'm going to do a very more formal introduction about constructor next week. Okay, I'm going to just do preview. Okay, I'm going to repeat the same information again. Okay, my math 2, I would say object number 1. Okay, is assigned to a new object of type my math 2. First of all, what does that do? Well, it does. Let's be a little bit careful about this. When I say new in Java, that means I'm going to create a separate portion. Well, I'm going to allocate a separate portion of my memory and store the information there. Okay? So that means I'm going to have somewhere in the memory over here. So it's going to be stored for the information of my math 2. And I know that my math 2 has only an attribute called foo. So I'm going to put a foo over here, and it has the value, let's say 0. Let me make it, let's say initial value is 4. Okay, let me just make 4 over there. Now you can see why I hate chalkboard. iPad is much better. Okay, so far so good. And then the reason that I call it object 1 is because you can imagine there's kind of like a pointer called object 1 that points to it. I'll tell you more about it in more details later, but just for the purpose of it was comparing. Not only that, there's only one instance over here. And remember I said, if they are non-static, you can create as many as you like. Okay? So now, let me do a different color over here. My math 2. Object number 2 is new my math 2 over here. Okay? Now you can see that again, let me use a different color here. What about pink? I'm again using the new keyword here. That means I'm going to allocate yet another separate portion of the memory. So I'm going to draw another different box, which means a different portion of the memory is going to store the same kind of information for my math 2. And then every my math 2 object has an attribute called foo. And I can do 4 here. But you can see the separate copies. We got 2 copies of the value 4, 2 copies. And then now this time it's called object 2. You can see 2 copies here, right? So now, if I simply say this, okay, after this, I'm running out of space. Let me use a different color here. No, yellow is not good. How about gray? After this, let's try something here. After this, if I say my math 2 dot foo. Now here comes the issue. Sorry, you were the person who asked the question, right? So now tell me something. If I say my math 2 dot foo, which copy am I referring to?
The copy from object 2.
Why not 1?
Oh. You have to specify.
You can specify, right? You can. I tell you what, if you do this in Eclipse, it's not good because it's ambiguous. Now we got 2 instances of my math 2. When you say my math 2 dot foo, you can either refer to the foo in the first object 1, or it can refer to the foo attribute value of the second object. We don't know which one. And for computer, you got to be precise. There should be no ambiguity, right? So this one here doesn't make sense. It doesn't make sense at all. So in this case, for non-static attributes or methods, we cannot simply use a class name to get access to them. we have to use object name. Okay? So this is not good. I'm going to cross it out and tell you what you should do. This is not good. It's ambiguous. Because there are two copies or two instances of my math2. Yeah, sorry about my writing. If you really cannot recognize it, ask me. I'll try my best to help you. I may not recognize it either. My math2, that's what it. Okay, so that's not good. So what should we do? What we should do instead is we should say, either we should say object 1 or object 2. You got to be specific. You can either say object 1 dot foo, or you might say object 2. It's really bad. Or you can say object 2 dot foo, right? Let me just put it back like that, right? So you can disambiguate it. That's in the case of non-static. We'll talk about things like this a lot when we get to the objects and classes. Okay? On the other hand, let's go back to our friend over here. That is the static case. In this case, because it is static, it's guaranteed there's a single copy of this particular utility class at the runtime. So when you say, okay, let me just put a note here. It's guaranteed. You might be wondering how it is guaranteed. Well, you don't care. Somehow the Java compiler or runtime is going to guarantee that. That's not your business, okay? It's guaranteed. It is guaranteed only one copy of foo will exist at the runtime. In this case, yeah, let me just finish that and then I'll get back to you. In this case, how do we access to that? So you can simply say my math dot foo. That'll be okay. Let's visualize that very quickly. So at the runtime, you simply have my math like a box over here, and then you have foo over here, and 3. You can see there's no pointer like object 1, object 2 as I did before. So there's only one single copy there. Yes, question. You know what? Technically speaking, you can. So I would say, as far as we're concerned for the first week, I don't want everybody to get too confused. Let's visualize utility. So we talk about utility classes. Let me make it very clear. Utility classes are a very special kind of classes because everything there is static. And static simply means there's only one copy for that particular attribute or method. Okay? So utility classes is very special. Okay? So there's only one copy for that particular utility classes. That's how we understand that. Okay? On the other hand, let's say you have something that is not a utility classes, in which case you can have as many instances as possible. The most confusing case, we'll talk about it for sure, for your knowledge later. We're going to mix static and non-static, but we'll get there. Okay. Question, please, since I've gone through this far, so I wouldn't mind any more questions about this. Yes?
On that screen, how did you get
public static int. That's a very good question. Okay, I would say let's not worry about that. I know the answer, but I don't want to confuse you. Okay, please, yeah. How about this? I promise if you ask me the question again when we talk about objects, classes, I'm going to revisit static again later. At that point, we can talk about it. Yeah, guys, it's not like I don't want to teach you, but it's better you don't know it for now. If you know it, you'll find that the world is too dark. Okay. Anyway, any questions as far as these are concerned? But for week number 1 and 2, we're going to learn about utility classes, right? So there's only one single copy there. Okay. So whenever you have static, use the class name to get access to the static attributes. When you have, in the cases where you don't have static, like in the next slide, you can create different instances. Don't worry about mixing cases. Don't worry about it. Please, don't worry about it. Questions? Are we okay? Good. Okay. Okay, so let's now go back to utility classes. Okay, so this is what I would like to do. We got about 20 minutes to, well, maybe more than that, maybe about 30 minutes. I think it is what I want to do. Let me see. So these are the things you can go over. Okay, that should be no problem at all. Okay, let me see. I do want to focus on the more important stuff. Okay, let's do some program tracing. How about that? Okay, so basically you will see that in the slides. If you look at the index over here, you'll see that so far we are up to here. We talk about visibilities, right? We talk about visibilities, and then now we're gonna see how you can define and use utility classes. Okay, so now I would like to do a complete program with you, not on Eclipse, but on my iPad. So I would like you to focus on what I'm trying to explain, and then you can try the Eclipse yourself. The code is already available to you, so you don't have to worry about typing it. Okay. So now, this is the program that I have. Okay, iPad. It's too small, right? How about this? Let me go individually. Let me go this one. Can you see it? Is that okay? Okay, very good. So now, I'm going to talk about two classes. I'm going to explain to you one by one. Okay. So, however, really pay attention to see if you got any questions, because for your lab test number 1, which is coming a little bit soon, you should really check your calendar. You will be expected to write something similar to what we talked about in the class. Remember what I said before, you don't have to worry about what they do in other sections. Whether they're easier or they're harder, focus on what I do in the class. Okay? That's why I'm recording. Okay, so now let's try to discuss this program over here. So now I'm going to ignore public, private, and non-public, right? We understand that already. That's about visibility. And first of all, I want you to notice that why is this a utility class? It's simply because you can see, wrong one. Why is this a utility class? You can see static here, static here, static here. So far, all the 3 attributes, they're static. You also get static here, static, 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 and static. Everything is static, so it is a utility classes. If I take out any of the static, it is not utility classes anymore, which is the most confusing cases, which I will avoid for now. Okay? So you got all static, so it's a utility classes. Next, I want you to look at, you can see that over here, just a quick review. Let me be careful with my color here. Okay, let's see this. You got final here, you got final over here. You can see for the attributes radius to diameter is 2. So I declare it as a final, so it's a constant. I never change that because diameter is always 2 times the radius, right? So it should be a final. And also pi should always be 3. Okay? On the other hand, you can see the radius over here, it is not final. So that means this radius over here is a variable. So it may be changed. So you will see that in the second class I'm going to talk about, I'm going to change its value very often. Okay? That's first thing to keep in mind. On the other hand, if I ever try to change pi, for example, I will get an error. It's not allowed. Okay? Okay, next. Let's talk about the methods. Oh, by the way, this is really something I would like to say. So how would you organize your Java code? I would say technically you're very free to the way you organize a Java program, because how you organize attributes and method, they can be completely interleaved. However, I would say if you really don't feel that confident, maybe, well, even for myself, for clarity, I always like to do this. I would say the first section here are for attributes only. Okay, and then followed by a section over here for methods. Okay, attributes followed by methods. It's a very dummy way of organizing things, but it's clear. Okay, it's completely up to you. Okay, so now let's talk about the methods. So we got 2 kinds of methods that I would like to talk about. First of all, let's look at the return type. So there are two kinds of methods. So for methods, we got two kinds. It can either be an accessor or it can be a mutator. Accessor means it returns something. Return, I'll say return something that's not void. On the other hand, if you see any method that returns void, it is mutator. Okay? And what do they really mean? Accessor simply means I want to get access to something without changing anything. Okay? Mutator means I want to change something. That's what mutate means in English. Okay? So now let's see what the mutators are and what the accessors are. Why don't we go one by one? I'm going to use, what about, let's say, green for accessor. Can you tell me which ones are accessors? Is this accessor, get diameter? It is, because it's integer. Thank you. What about get diameter? Oh, this one as well, right? Also integer. I'll talk about parameters in just a moment. Okay, let's not do one thing at a time. What about set radius? No, it's void. Very good. And this one for sure gets circumference and also get circumference 1, get circumference 2. So it seems like we have only one orange, only one mutator here, right? Different categories. That's how you can tell. Screensaver. You know what? Let's do this once and for all. Otherwise, I'll run into the same trouble tomorrow for 3311. Screensaver. Let's go for extreme. Never. Go away. Not you, I mean the screensaver. All right. Good. Okay. So now that's about the difference between mutator and accessor. So next, I want you to focus on these two methods over here and then talk about them. Let's focus on this method here and this method here, right? They have the same name, don't you agree? However, you can see that within the pair of parentheses, they are different. So that is allowed. This is something, do you know what it is called in Java? Overloading or overriding. Choice number 1, overloading. Choice number 2, overriding. 1 or 2? 1 or 2? I heard 2, okay. If it's 2, overriding, no, not overriding. Overriding means something completely different. When we talk about inheritance for objects, we talk about overriding. It's called overloading. I will just write it down and then explain. First of all, I'll put it here. We say we overload, okay, overload the method get diameter. Get diameter, okay, with different parameter list. Okay, let's first talk about this particular vocabulary over here. When I say parameter, that means I'm talking about when I'm trying to define a method, I'm declaring what the inputs are. Okay, parameter, the way you can understand it is input. Oh. Let me get rid of this. So parameter simply means input. Okay, so you can see in this method over here, no parameters, no inputs. Over here, one input. Okay, so far so good? As long as you can give different input lists. In this case, there's one empty list. Another one, it's a list with only one input, so they're different. That's why you can use the same name of the method. It's called overloading. Can you see another instance of overloading there? Get circumference. Really? No, right? If you look at line number 16, get circumference there is a name. 19, get circumference 1, different name. Line number 22 gets circumference too, it's different name, so that's fine. So for example, it can be a nice lab test question. I give you, for example, the code. I will ask you, for line number 19 and line number 22, 19 and 22, are they an example of overloading, true or false? False. False, right? Good, false. I'm pretty sure it's false, yeah. You can take my word for that, it's false. Okay, very good. So now, one more, several things to mention. Any more questions, please, before I move on? There are quite many things to talk about in this particular thing here. I'm gonna use a fresh diagram again in just a moment. I'm gonna upload the notes as a PDF, don't worry, since it's stored in the iPad. Okay, yes? If you didn't have the, that's an extremely excellent question. Let me hold on to it. I'll get back to you in just a minute, okay? Because that's exactly what I'm gonna talk about, okay? So now this is a little bit messy here, so I'm going to just add another page. Give me one moment. I'm gonna add a page, and then I'm gonna add that image again. Photos, and then make sure I choose the right one. Can you do this on chalkboard? Can you? No, no way. Of course not. If you can do it, let me know. I would like to learn. Okay, now it's the same code over here. So now get back to your question, okay? I heard something about smartboard. I tell you what, it's never going to happen in this school. Never, never, ever. Unless you pay double the tuition, they might do it. Well, I'm not sure about that, yeah. Yeah, well, that's true, but anyway, that's another issue, okay. Okay, so now I would like you to focus on, let me highlight the thing I want you to look at. Now, I want you to look at this particular method here, get diameter radius, okay? Okay, now, and then I'm going to also highlight this particular static attributes. First of all, don't you agree? Line number 3 and line number 10, we have two things have the same name, right? Line number 3, we have a static variable called radius. Line number 10, we have an input parameter for method get diameter, which is also called radius. Okay, it's legal. I'm just trying to tell you how we're going to solve that. Okay. Now, how can we do this? Okay. Now, and then I'm going to complicate the matter a little bit. Let me now also highlight this radius over here. So now, tell me something. The radius in pink, is it referring to the radius at line number 10, or it is referring to the radius at line number 3? 10, that's correct answer, okay? And there's a word for that, it's called shadowing, okay? I'm gonna write it down, don't worry. So the radius over here refers to the radius over here. We talk about it, okay? It's called shadowing. Shadow. So somehow, you see somehow the radius as an input parameter, it kind of shadows, because you can imagine the radius over here is like a sun, right? You can shadow it, so you don't see that anymore, right? Temporarily. So inside this method here, when we refer to radius, it's referring to the input parameter. Now, you might be wondering, can we ever, once it's been shadowed, can we ever refer to the radius at line number 3 anymore? Did somebody say casting? Class name, oh sorry, not casting, class name, exactly. Yeah, so you can use a class name. So now I'm gonna put it as a note. Due to shadowing, if you want to refer to the radius at line number 3. This is what you have to do. You got to use a class name. You're going to say circle utilities, right? You can see that circle utilities and circle utilities here, right? I'm using the class name over here. And then circle utilities dot radius. Okay? That's what you're going to do. Yes, please. Oh, this, right? I would say don't worry about it for now. Because when you talk about this, that means we talk about some non-static, like a non-utility classes. We'll get there, don't worry. Yeah, it's very good you mentioned that, but we'll talk about this next week, maybe. Okay. Okay, so now let me just refer to another method here just to strengthen your understanding over here. So now, question for you. Let's have a look at this particular method, another method there. Let's have a look at set radius. You can see the input parameter name is called new radius over here, right? So now when I talk about new radius over here, there should be no ambiguity. Okay? Now, question for you. Okay, I'm going to use a red. So now I'm going to say for this particular method here, like that. Now I'm going to give you two variable references. Over here, if I say radius, that's number 1. Number 2, circle utilities dot radius. Number 1 and number 2. Okay. Now I'm talking. So the context is really important. Now I'm talking about I'm within the context of set radius, where there is no shadowing because the parameter name is different from the attribute name, right? So now tell me something. Do 1 and 2 refer to different attributes, or they refer to the same? Same. Okay. On the other hand, I'm going to write it down in a moment. Let me ask you this. Also, options 1 and 2. If you put these two options in the context of line number 10, the method get diameter over there, do they mean the same thing or different? They mean different things because now there's a shadowing. Okay? Now, I'm going to write it down. You see, that's kind of many, so this example here really illustrates many small details, so please study this very carefully. Okay? So now I'm going to say these two options over here, I would say these two over here for method at line number 10. Line number 10, where there is shadowing. They mean the same thing, right? In this case, they are the same. Sorry about getting a little bit messy, okay? On the other hand, if I say for method line number 10. Oh, I beg your pardon. I said the wrong thing, right? They mean different. Okay, I'm so glad you're not dreaming. That's good. That's good. Yeah. That's good. That's good. Okay. So please watch the recording. Make sure you really understand what I'm trying. Okay, let me make it very clear. If you look at, let me just repeat that, and then I'll write it down properly. Otherwise, it's even worse than not talking about it, right? Now, for line number 10, we get this particular method over here. Okay, there is a shadowing because the input parameter has the same name as the attributes. So there's a shadowing. In this case, for option 1 and option 2, they mean something different. The number 1 talks about the input parameter. Number 2 talks about the attributes at line number 3. Okay? Now, I'll say difference. Okay? Now, for the method at line number 13. In this case, line number 13 over there, let me use also yellow, that's fine. Line number 13 over here, you can see that there's no shadowing because the parameter name is called new radius, which does not clash with the attribute name. In this case, if I use option number 1, radius, it does refer to the attributes. If I use circle utilities.radius, it also refers to the attributes because there's no shadowing. Be careful. In this case, they are the same. Okay, they're the same. Any question about this? Yeah.
So for line number 12, we change radius to new radius and the line stays unchanged.
I see what you mean. Okay, I'm actually going to trace the program in just a moment. Okay, let's have a look very quickly. Let's say for line number 11, so here you can see we are returning radius multiplied 2. And this radius depends on what the input parameters is, right? So it has nothing to do with the attributes. Agree? On the other hand, if I do line number 13, the set radius method, if I pass number 5 to change, that means I'm going to change the radius attributes to 5. Right? If I say set radius to be 7, I'm going to change that too. Okay? I'm going to show you the program to see all the effects, right? But it's good to go over this first before I move on. Okay? Okay, so now let's now get something that's also very interesting, but I'm running out of space, so I better add another page. Let's get our friend back. Okay, it's not here. Okay, now I want you to look at these methods. There's one here, and also this one here. Okay, so the idea I would like to illustrate to you is something called helper methods. Okay, I'm going to write it down. And the idea is very simple. So now the way you should really think about methods is that a method is simply a block of code. Okay? Don't worry about the highlight over there. Somehow, you didn't move the highlight at the same time. Okay? Okay? A method is a block of code which can be reused by referring to its name. Okay, that's what helper method means. Okay, for example, you can see that. Let's see how we implement this particular method here. Let's say for this one here, you can see inside this method get circumference, which takes a radius, right? I'm simply trying to say get diameter and then pass the radius. First of all, you can see that over here, this radius means this radius because of shadowing. First of all, that's what we learned. It's called shadowing. What about this get diameter here? Where was that defined? Which line was that? Is it line number, okay, good question. Is it line number 6 or line number 10? They are both called get diameter. 10. Cannot be 6 because the get diameter method defined at line number 6 takes no parameters. So it's got to be the one at line number 10. Okay, let's get that clear first. So this one over here means we have this one here. So we're calling that. Again, the way to understand method is it's simply a name block of code. And once you declare the method there, you can reuse it. Okay? And once you get to 3311 later on, it's called software design. So there is a design principle here you should really learn. you should really avoid duplicates as much as possible. Okay? In this case, if I can call the get diameter at line number 17, I should do it. I should not repeat the same code to say it should be radius times 2. Again, I can just call that method, right? Okay. Okay, so now I'm going to talk about how you can trace. Okay, let's just give you one example here. Okay, let me give you one example. So let's say here, can I just use CU for circle utilities, okay? If I say CU over here, dot, let's say get circumference. And number 3. Let's not do 3 because that's a little bit confusing. How about I do 5? Okay, let's say I'm trying to call this static method over here, get circumference 5. First thing first, I'm going to discuss how this is going to be executed at runtime. Okay. So first of all, it's called. Let me use a different color here. It's called get circumference over here. So which line is it going to refer to? Method. 16? Good, very good. I'm going to circle that. According to line number 16, there is a method called get circumference, which will take an integer radius. In this case, the radius over here is going to be instantiated or replaced by 5, right? Okay. So now I'm going to say, so now, you know what, to really make this 100, why don't we get another page? Okay, so now let me just write it down again, and then we'll do that properly. Because we'll see lots of this in the second class. Circle utilities dot get diameter, get circumference. Number 5. Okay. Let's say that's what I want to do. Okay. First of all, I know that get circumference is referring to this method over here. Okay. And then, another terminology for you. What I said before, this radius over here is called parameter. So the parameter, which is radius, can be any integer. So this integer can be 5, can be 10, can be 20, can be anything. That's an integer. Now, for this particular method call over here, I'm giving radius the value called 5. And the 5, we don't really say is a parameter. It's called argument value. Okay? Argument value for replacing parameter radius. Okay, so the radius is called parameter. The number 5 over here is just one example that you can instantiate or to replace the parameter. Let's give you another analogy here. Remember when you learn math, if I say I define, let's say I have, for example, factorial of x. You know what factorial is, right? It's going to be x multiplied by x minus 1 all the way to 1. That's the definition for the factorial. In this case, we will call the x over here as parameter because x can be instantiated to an infinite number of possible values, right? So this is called parameter. So now what about arguments? There's only one parameter, which is x, which tells you what should be the type, how you should use the method, use the function. On the other hand, if I say factorial 5, factorial 4, and etc., the 5 and 4 and 3, or any numbers there, they're called argument values. The 5 The 4 over here, they're called arguments. Since we are scientists, we want to be precise, okay? When you talk about parameters, you really talk about in the context of defining the method. When you talk about arguments, you really talk about when you're trying to use the methods, in which case you can use in a number of different ways. Okay? So now let's go back to this particular method call over here. Okay, let's go back here. Now, since I'm giving 5 over here, so I'm going to replace the radius by 5, right? Every occurrence of the radius is going to be replaced by 5. So this one, because of shadowing, I'm going to replace that by 5 as well. Get diameter. Agree? So now you can see the helper method call. So let me just highlight that. It's get diameter 5. What it is going to do is going to go for another level of indirection. So which line would it go to? 10? Good. So now in this case, we're going to instantiate that to be 5 as well. Again, we got shadowing. We also get 5 over here, right? And we know that this one is already defined as 2. So we get 5 times 2. Okay? To be more precise, let me just say a little bit more. So that means this expression that we talk about back there. So the way you can understand helper methods is by using something called unfolding, which you do a lot in mathematics. Not university mathematics, elementary school mathematics. It's called unfolding. Let's see how we can do that, okay? So for this one here, we know that by definition, this is equal to this. Cu dot get diameter of 5, and then multiply by pi, which is 3. And we know that in turn, this refers to the definition of this. It's going to be 5 times radius to diameter, which is 2, and then times 3. So you'll get 30. Right? That's how you do unwinding, unfolding. Any questions? Okay. Yes?
Line number 13, when you said radius equal to radius, does that make the radius minus 20 radius?
Does it make it? Okay. You know what? I will maybe talk about it. Yeah. Okay, guys, let me spend 1 more minute. Okay, I'm a little bit behind, but that's okay. I think it's got to be clear. Do me a favor. I'm going to upload a recording, and I'm also going to give you all the notes I took today. I want you to go over them thoroughly for the preparation of Thursday. On Thursday, I'm going to use a program and then trace it to show you again to emphasize the points. And then we're going to talk about some other simple stuff, and we're going to move on. Okay? See you on Thursday.